This movie shows a pill falling into a glass full of water, and actually the motion is very smooth here because it's taken with something like 50 frames per second. Now, how can we observe events that are 1,000,000 of a billion times faster? Just a clue, there exists no camera with a shutter which is fast enough. My name is Biegert and I lead the Attoscience and ultrafast optics group here at ICFO. Our group works in the attosecond regime, which means that we are making and using attosecond flashes of X-rays to look at the location and the motion of electrons inside atoms, molecules, and also solids. Now, why do we do it? Because this location of the electrons, or how they behave, determines basically everything that surrounds us. For example, how a chemical reaction is triggered, or how a biological function is initiated, or for example, how sunlight is converted in a solar cell to energy. Let me give you an example. Thalidomide is a drug which was described in the 60s against nausea and sickness, mainly to pregnant women. And what was not known at the time that the chemical reaction leading to this drug results in two end products with equal likelihood. Like the two hands that you have, they're mirror images of each other, but they are not identical. The problem was that one of these end products was effective as a painkiller, but the other one produced crippled children. Now, it is important to study the motion of the electrons because they determine how a chemical bond is formed or broken, and therefore determine whether you produce one end product or the other, for example. So not only could we prevent such horrible disasters, but it would also lead to the possibility of controlling chemical reactions or producing even completely new materials and drugs. The superb challenge is to look at such electronic change since it happens on the fastest known timescales, on the attosecond timescale. 1 attosecond is a number with 18 digits behind the comma. And this is, of course, hard to imagine. So in fact, 1 attosecond is to 1 second what 1 second is to the complete age of the universe. Now, how do we make such an attosecond camera, since there exists no shutter which operates on such an incredibly fast timescale? In fact, we use X-ray flashes of light and use it like a disco strobe light. We illuminate the process, the electrons. We take one small snapshot and then repeat this at different times to reconstruct the motion of the object itself. The next couple of years will be extremely exciting because it will give us the tools to generate new materials, new medication, new products, and to investigate the processes behind all of this on their intrinsic timescales. That means that we can, for example, look at the triggering events behind biological processes that lead, for example, to cancer or to Alzheimer's. I always wanted to do science because it gives me a chance to look behind the curtain, to watch the inner workings of nature and to hopefully learn from it. And attoscience is a field which is so multidisciplinary that it draws from many different fields of physics to do exactly that.